Alright, yeah. Good afternoon. 저도 좀 어색하지만 네, 한국 분들 많은데 앞에서 영어로 하는 게 좀 어색하지만 영어로 한번 해보겠습니다. 네. Good afternoon. My name is Kiyeon Pyo, Research Associate at E3 from North Carolina State University. Yeah. Actually, Professor Lee Kim invites me, this seminar and tutor lab. So actually, I requested to visit, his tutor lab, and because I really wanted to see simulator devices in person. So thank you for giving me this opportunity. Really honored to be here as a speaker. So thank you for taking your time here. So my presentation title is Application of Alternative Intersection Design using Driving Simulation Study. So let me move the next slide. Mouse 때문에. Yes, okay. All right, so contents. So the first one is let me introduce myself quickly about me. And then I'm gonna show you the several type of alternative intersection and interchange. Also, I'm gonna share the geometric background about the North Carolina. I think we need to understand about this a little bit. And then I'm gonna give you one of the example as a research project from NCDOT. Project name is Design Consistency on Corridors. I'm not gonna explain in depth today, so maybe if you have any further questions, feel free to email me anytime. I will let you know. And then first one is driving simulation lab. So I'm gonna share my experience as a driving simulation lab manager. So, and then conclusion about research. So today's my presentation is overarching, starting from about me to about research. Introduction about me. So I think, showing the LinkedIn page is the simplest and the best way to introduce myself quickly. That's why I put screenshot here. So I got a bachelor degree from Kyung University, civil engineering, and then 2014, I started a master degree, transportation major at North Carolina State University. After 2 years, my thesis title, my advisor, Dr. Raphael, he's really interested in developing a highway capacity manual using the big data. So my thesis is related that. And then after 2 years, I got a master degree. And then my first task was creating driving simulation model. Since then, the journey of my role is starting from research assistant and then research analyst. It is called like a senior designer for the driving simulation. As a research associate, and also I'm working as a lab manager. So since then, 2016, so I've been working with simulator around for 9 years. Time so fly. This picture is the NC State University Centennial campus. This campus is focused on like engineering and science. And then I work at E3, Research Building 4. E3 is kind of institutional center at North Carolina State University. So E3 is focused on not only research, but also education. So it is for municipal, state, federal, international clients to address the critical transportation issues. So through our work, we are proud to mentor around approximately 100 graduate and undergrad students annually, so providing them with reward like a professional experience. E3 staff members around the number of E3 staff member is around 80 people. Yeah. So actually, I'm not a PhD. Yeah, I'm not a philosophy. I'm not a doctor, but I just got a master. But I would define myself as a professional engineer instead of a PhD, philosophy or principal investigator. Also, I'm not an expert about new technology and statistic model, but I think I'm an expert for the driving simulator, for the roadway safety. And then I'm also middle person between the professor and students. Also, I'm collaborator with other departments like industrial engineering, psychology, and neuroscience, something like that. So yeah, I'm going to explain further later. About NC, yeah. I'm gonna tell NC, which means it's North Carolina, where I live. So anybody ever been in North Carolina here? No? Oh, where?
Where in North Carolina?
Yeah.
I don't remember the city, but I visited.
Really? When?
A couple years ago.
Oh, really? Wow. Nice to meet you. Yeah. Honestly, there is no special tourism site like LA or New York, but North Carolina state is very beautiful, I think. Yeah. So, do you know Pepsi Cola and Krispy Kreme donuts? Yeah, these are origin from North Carolina. I'm not gonna advertising anything, but I will, I will share this fact that our state, North Carolina state, is first in flight state. So all vehicle drivers, license plate is like the first in flight. That's why. This is because Wright brothers in Korea, like Hyungjae, they achieved their first success in here. Yeah, Outer Banks. Yeah, wind a lot. So, and also, do you know where is the popular and famous national park in U.S.? I think Grand Canyon National Park, right? But Great Smoky Mountain, located in here between Tennessee and North Carolina, is very huge national park, and then the number one most visited national park in U.S. Yeah, the top. So I'm so proud about this. And North Carolina, population is ninth largest population in the U.S. And size, geometric size is larger than Korea. 40% more. But capital is yellow box, Raleigh, where I live, and then where, North Carolina State University here. Raleigh's population is around 500,000. But I found that Daejeon's population is 1.5 million. It means, 3 times more. Yeah, which means I think population density is considerably lower than Korea, which means traffic congestion is not too severe, and then atmosphere is very quiet, and the air quality is also very fresh. Yeah, they are usually suburban and rural area, and which means is they are possible to locate and install places for the alternative interchange type instead of standard and typical intersection. So I'm going to show you the several type of alternative intersection. So in order to understand well, I think, knowing this background is better to understand. So DDI, have you ever been seen like this interchange? No? means is diverging diamond intersections. As you can see here, a little bit, yeah, some section traffic is reversed, right? Another case is quadrant intersection. I think this is a very similar is Piton in Korea. Yeah, the tour. Arca is the most popular intersection type, means restricted crossing U-turn. So center point is blocked. So driver should, in order to make a left turn or go straight, driver should use a U-turn over there, detour. Next one is CFI, continuous flow intersection. Yeah, it is very similar standard intersection type, but conflict points moved earlier here, and then distribute some traffic, and then you can see some section where traffic reversed like this. Also, mud is very similar, are cut. So in order to make a go straight and go left turn, the driver should use the detour by using the U-turn like this, because it is blocked center point using the pavement marking. So as a see a map, US map, now existing AII designs number of how many alternative intersection. As you can see here, DDI, RCUT, and MUT, these three majority types in the US. Total number of is 470, but I think you noticed that it's not can see well, but red box. Here is the North Carolina. As you can see here, North Carolina state invested a lot and interested a lot about the alternative intersection type. I counted, total around 100, which means it's a 20%. It is quite highly rated in North Carolina. So FHWA, Federal Highway Administration, they published manual and guidance at each intersection type like this. So 4 years ago, each team, NC State team, research team, participated for the DDI, Diverge Diamond Guidance, second one. So I will explain about the one project from NCDOT. As you can see, we collaborated with University of Florida. And Dr. Caber, he is an industrial engineering professor. So his team is in charge of human factor. So he's working with statistical model and using the eye tracker in order to analysis. And then each team set an outline, methodology, experiment, and then analysis. The outline, specifically the first one, driving simulator experiment. I focus on that step. So research background. So I think if you can drive, I guess you may know the concept of permissive yield left turn. In Korea, 비보호 좌회전. So as I mentioned earlier, there are a lot of possible sites to install the permissive yield left turn at North Carolina because there are a lot of suburban area. So we don't need a lot of standard intersection controlled by the signal, typical. But cons is one of the most dangerous movement. Actually crash and injury is very high at this point, permissive yield left turn movement. So NCDOT's answer was alternative intersection, specifically, North Carolina area. It enabled to redirect left turn and other movements to reduce number of conflicts and signal phases. Also, this one, alternative intersection is enabled to improve traffic safety and operation along suburban, actually suburban, not city, not urban, suburban or rural corridors. How? Increasingly number of alternative intersection. So the research team, had questions ourselves. So some alternative intersection is not familiar, right? Unique. So if driver understanding well or not, or actually, recently there are a lot of ARCA type in North Carolina now. So do we need to keep or not? Also, third question is, if we make a paired intersection, two intersection, which one is the best combinations? This one is our questions. So before that, it's like a literature review step. So there are a lot of type of intersection and interchange, total 41, right? So based on that, we collected all possible specification and organized all features for the each types. And then focus group is sort of a pre-survey. So in the real field, we choose the 6 routes, including ARCOT, and then we record the video, and then 17 participants watch the video. We got some result. So based on the research team's hypothesis, pavement marking is very useful. And then adequate and then advanced warning sign is very useful, more needed, actually, for the alternative intersection area. Between overhead and the side-mounted sign, overhead sign is better. Also, directional information like north, south, 동쪽, 남쪽, something like that. This information is not useful in the case. As you know that the standard intersection is like this, right? The regular one. RCI, RCOT intersection. I created this model, so driver want to go through from here to there, and then driver should use the U-turn like this, the detour, and RCOT. Median U-turn is very similar. Quadrant is like a P-turn. So the research team choose total 6 test movements like this. Based on that, we made 12 combinations when we make a paired intersection. So there are 2 things, right? The first one is a preceding intersection. We call the second one is a testing intersection. Actually, we're interested in correlationship between them. And then, based on the 12 combinations, we made 9 experiments. This order is regularly or randomly. I will show you. I think this satellite view is easier to understand. So this one is the first experiment. As you can see here, driver started here, went through total 12 intersection type, like this. It's like an escape maze, right? So there are second one, third one, fourth, 5, 6, 7, 8, 9. They're totally different experiment type. So one participant, one driver went through total 9 experiments for 3 hours. They followed by the blue message like guidance, like a GPS. This one is a simulation view from the control center. like this. All right. Yeah, this one is NC State simulator. I will explain to be more detailed later. All right. So 48 part. At least this for this project, we hired 48 participants because COVID area, seasons, so it is hard to hire them. So we hired 4 different groups, like a male, female, young, and middle age group. So total 48 participants. Each participant went through the 9 experiments for around 3 hours, and each each experiment takes around 10 minutes. And then we paid $20 per hour, the time. About the performance measures. So we interested in 3 factors. The first one is critical performance measures, like a failure movement. And then second one is about the distance time performance measure is related average speed and the number of lane change. Third one is comfort performance measures. So, how frequent hard braking at the specific area and specific intersection. Actually, the second and third performance measures, we can get a data result from the trajectory data from, simulation motion-based CSV file. All right. This one is abbreviation. For the statistical study, it's not important now. Okay. Actually, depending on the performance measures and each, depending on the intersection types, we choose the suitable and proper statistical model. Before the 3 main results, I will show you the pre-result about that. So the research team expected this situation because trial order was very significantly associated with failure movements, because the first, this one is the first trial is a lot of failure movements. It is, so sure. You can expect this. First result, failure movements at test intersection. As I mentioned before, we have 2 intersection paired. The first one is the preceding, second one is test, right? Preceding intersection, when we put the R-cut preceding intersection and then produce the greatest failure movements. The second one, test intersection configuration, usually median Newton intersection is a lot of failure movements. So I'll show you again to repeat. Preceding, when I put the R-cut as a preceding, there are a lot of failure movements. Second one's MUT as a test intersection, there are a lot of failure movements. Again, so this combination is very hazardous, and then severe crash or something like that. Second result is about the average approach speed. So R-cut movement go through, and then driver usually high speed at this type, low speed at this type, MUT. Last one is the hard braking events, HBE. So many drivers, usually a lot of the hard braking at here, quadrant main left turn, and MUT around 30%, like this. So drivers encountered this type of intersection. There are a lot of they have tendency to hard braking a lot. General findings. I will show you the general findings. So we hired each groups like a male, female, and then not old, a middle-age group and then young age group separately. That's why we want to see what is the difference between them. But I think 48 sample size is very lower than we expected. So no significant difference between them actually at this project. And then okay, there are a lot of factors too. All right. I think this one is a red one. This one is the greatest achievement for this project. So preceding intersection type was significantly associated with failure movement. Specifically, R-cut preceding intersection type produced the most failure movements. Yes, around 60%, more than 60% is very highly quiet. All right, so when it comes to design consistency, corridors project that I explained so far, we want to see the performance measure result depending on the combination of each unconventional intersections type. This one is a previous project. This is GSIX project. It is about the roadway signing and marking, conventional, at grade separated intersection. Grade separated means it's a different height. We usually use them at the highway area. So, for example, which one is better to look? Which one is the better between the overhead and side-mounted signage at the specific area, or where is the best location pavement marking at the grade separated intersection? We're interested at the time. Second one is the DDI project. As you can see, some reversed area, right? So from the usually, in order to access DDI, it is very important to access the look-back angle. So using the eye tracker, we found what is the look-back, what is the best look-back angle to access the DDI. All right. So let me start. I'm gonna share my experience as your driving simulation lab manager. There are 4 subtopics. First one is software, and then second, simulator, experiment, and then collaborative work. Software, whenever I create the driving simulation model like this, I created this simulation manually, time-consuming work. Whenever I created a driving simulation model like this, I was so excited and feel like achievement. It allows me to realize detailed environment with 3D large-scale model. This program is UCWin Road. Company name is Formate, made in Japan. But however, this program is sometimes very heavy. So I encountered unexpected issues like not responding. I think some of you will relate to these problems if you are model developers. So actually, design consistency project that I mentioned earlier, like this, whenever I merged them, it was hard, for me at the time. Simulator. About the simulator, there are 3 main parts. Motion-based, it's called MOOC, driver cockpit seat, and then 7 client PCs in each. This one is a motion-based. It is from LS Sanjeon, yes, in Korea. This cockpit seat is, we got from the Hyundai. And then When we built this simulator 10 years ago, we choose 55-inch TV, and then we set up 7 TV monitors surrounded the center cockpit. And then each desktop client PC is connected to each monitor like this. This one is a wireless sound system. So in order to operate the simulator, I had some various kind of issue like this. So file type issue, driver seat power problem, plug-in issue, motion-based connection and software issue. There are a lot of issues. So actually, solving this problem is my main job. But sometimes I need to ask, and then I need to ask to other coworkers and experts. So while preparing these presentations, I was reminded my coworkers, there are a lot of working together for the one simulator. That's why I put this name. Sorry. Chris Cunningham, he's my supervisor. He always proposed the driving simulators features. Justin is the industrial engineering, technician director. He always helped a lot to figure out and how to fix that. Dr. Caver, he's in charge of the human factor, from University of Florida. Chris Kahns, Chris Vaughn, they helped a lot when we built this simulator. Brandon and Patrick, they are middle person. They live in United Kingdom, England. They are middle person between us and then headquarters in Japan. So Yohan and Masahiro, they are experts. So when I got a serious problem, and then we had a lot of Zoom meeting with them. So they helped a lot. Seth is an IT technician at E3. Simple issues that he usually solve problem. Lisa is graphic designer. Luke is coordinator. So they focus on the how to advertise and promote about the simulator, the university. Emily is my assistant. Hillary is a recruiter. Oliver Amy is host. Visha is focused on coding. Yulin, Yumei, they are PhD students. They are from the industrial engineering and the neuroscience engineering. Which means, we had a lot of collaborative work. Experiment. So as you can see, this seat is the progress experiment seat. So in order to do this, we had to recruit. We have a one staff member. Hillary, she's focusing on the promoting and hiring people, something like that. So in order to hire the various kind of random people, like male, female, and each old age group. So she posted all possible ways. She posted the regional community and notice board and social network service, something like that. And then in order to make one experiment, we need at least a host and then one technician. Host's role should explain for the drivers and then follow them and then doing SSQ. So pre-survey is a body condition. Technician should turning on the simulator, running simulator, and then recording data and then trajectory to keep a track of data. So SSQ is like a survey to check the body conditions for the participants. It is based on the TLX, NASA TLX, task load index. So based on that, we can see, we will be able to see the participants' the general discomfort or nausea and headache, something like that. So, at the seat, white marked is canceled because around 10% of participants is a very heavy, severe nausea and a headache. So we had to cancel that schedule. Sometimes, yeah, it was very hard, yeah, hard for me because sometimes someone is no show, suddenly they are not available. Yeah. And then I will share the one story. Okay. When I do NCHRP project and DDI project, we have to hire 180 people, 60 middle ages and 60 young people. At the time, it was hard to hire old age because old age group should be over 64. Yeah, it's too high. Then one, yeah, old man. Yeah, I remember his age was 87 at the time. Yeah. So his driver license, the issued year is 1948 in New York State before the Korean War. I was surprised at the time. So for 2 hours, yeah, he's very, yeah. His driving was so impressive and then no nausea and no headache. 오늘은 70년 운전 경력의 87세 할아버지가 운전 중이시다. 70년. 예, 70년 운전. Respect. That's why I put my Instagram story. I was impressive experience and unforgettable participants. Last one is collaborative work. SIMPACT, simulating people-centered and adaptive and connected transportation. It is sort of the partnership with university departments and affiliated labs, utilizing simulator platforms to conduct cutting-edge technology and research in human factor, unconventional intersection designs, and more. So, okay, a lot of, civil engineering, they have 3 real cars. Yeah, they use the LiDAR sensor and then collect the data. Also, industrial engineering usually use the eye tracker, using the People Lab program. So applied cognitive psychology laboratory, they had a Tisim lab simulators, a small simulator. And then they usually use the heart rate monitoring system and the EMG devices. Actually, I'm not expert all device like this. I just want to show you the how to collaborate with other department like this. My main role is to operate, providing or possible way to operate the simulator. So, for example, creating roadway and intersection, interchange. Also, I can develop the customized model, background, or specific scenario, and operating special function, ACC, adaptive cruise control, and LKA, lane keep assistance system. Also, I'm also providing training students. A lot of PhD students at each department. So, how to use the simulator, how to develop the simulator simulation model, and how to use the operating other functions, something like that. So, as you can see here, there are a lot of various experience from other department. For example, applied ergonomics, NIH. Actually, National Institute of Health, they interested a lot about the cognitive elderly driver, right? Because of safety issue. Electronic engineer, and then applied human factors, and then AAA. It is about the accident for the safety. So through our work, I could get various experience to cultivate the performance and then various research papers. All right, conclusion about research. 2 years ago, 1.5 years ago, I was invited the first World Congress of Korean Scientists and Engineers in Seoul, 강남, 제1회 세계 한인 과학기술인 대회. I was invited actually this session, advanced mobility sessions, we had a lot of discussion about the advanced mobility, about the cutting edge technology, how to use the device, something like that. But the most talked about at the time, the most talked about was a research difference tendency between Korean and Western countries. Yeah, it is interesting. Yeah. So this time it is a very good time for me experience because it was gave me a realization. It was to accept redundancy. So when you do research, we tend to keep trying to find something new and new, right? Yeah. If the topic has already been done by someone else, we tend to move and switch to another direction. But I think even though the topic has already been done, was it really good? Yeah, sometimes I think you may know, and then I think you agree with that. So some paper and some topics, a lot of could be cons and deficiency in previous research. So even though the topic and the paper is published by the authorized and then famous institute, and then when we do it again with the same topic and with a new team, and we can get more accurate and then we can get more productive result, I think. At least we can get the good experience and then in the process. I'm also Korean, so I usually, when I work, I have a tendency to do things so quickly, so fast. But compared to Korean, many American, usually they are very slow. But I think this is the very difference between them. But they are very cautious. They are very careful. They are very relaxed, I think. So I realized that I can remind about this is important, that quality is better than, or quality is important than quantity. Okay, I think this one is the last slide, right? Okay. One senior, the senior who led me to the transportation field, he said that research means is re plus search. It's just like the name. So we should search again and again, even though the topic has already been done by someone else. Just think, no. Just doing something, it's no. We should do repeated research again and again. As I mentioned earlier, my precious coworkers, we cannot do alone, I think. When you do research, we should do research together. 마지막으로 이 부분은 한국말로 마무리를 하고 싶어서 이게 조금 번역이 맞을 수 있을지 모르겠지만 그 당시에 제가 너무 공감을 했었던 건 중복성을 인정하라라는 말이었었어요. 그래서 첨단 모빌리티 얘기를 했지만 그거보다 더 많은 얘기를 했던 건 이 자리는 외국에서 활동하는 한국인들의 과학자들 모임이었었기 때문에 한국인들과 외국에서 연구하는 사람들의 스타일, 방식, 그런 거에 대해서 얘기를 하게 됐을 때 많은 한국 사람들은 했던 거를 또 하는 거에 대한 두려움이 많다는 얘기를 했었던 게 있었어요. 그래서 우리는 항상 새로운 걸 찾아야 돼. 찾아야 돼. 근데 이 얘기를 하기 전에도 또 최근에 수많은 박사 과정 학생들 이렇게 만나면서 얘기하면은 저도 이런 얘기를 많이 하더라고요. 새로운 거 하는 것도 좋지만 했던 거 다시 한번 해보는 게 좋을 수도 있다. 생각보다 더 좋은 결과가 나올 수도 있고, 그러니까 이거 했던 거니까 다른 거 해! 라는 말을 들어도 두려워하지 말고 해보는 거. 중복성을 인정하라라는 그게 정말 요즘 또 필요하지 않나라는 얘기를 했었던 게 너무 저한테는 그때 많이 와닿았어가지고 오늘 프레젠테이션을 준비하면서 이 얘기를 꼭 같은 내용이지만 한국말로도 꼭 말씀을 드리고 싶었어요. 정확하게 이게 redundancy, accept redundancy가 중복성을 인정하라 라는 말이랑 똑같을지 몰라서 이렇게 한번 마무리를 지어볼까 합니다. 그래서 계속해서 찾고 또 찾는 여러분들이 되시고, 대학원생들, you are graduate student, right? So you should research, search again and again. Yeah, how, think and do both repeatedly, how, not alone, together. Okay? Yeah, thank you for listening today. My presentation. If you have any further questions, I can send some materials, attachment, reference about the project, and then thank you very much. 오늘 들어주셔서 감사합니다. 이거 꺼야 되나요? 질문, 네.
So I'll start first. Hi, I'm Yosan. Thank you very much for your nice talk. I'm not really in this field. So when I hear your talk, the immediate thought I had was you did some simulation study to understand certain impacts and to conduct the analysis.
Yes.
And I wasn't really sure how you do actually analysis. Is it like based on some statistics? I thought you tried to find some correlations between the factors.
Mm-hmm.
So what are the typical methods you are using in order to do analysis to find out the correlations or maybe causalities and so on?
Correlation what?
Or correlations between the factors or causality, so like cause and effect, because correlation doesn't mean that this is caused by something. So therefore, maybe I thought it is important to understand the causality too. Do you use, so for example, you have used 48 cases in the...
For your participants? Yeah.
Yes. And I guess you conducted some analysis to conclude something. So you concluded using this one is better, using this one is not better. In order to conclude, you must have used, I guess, some sort of techniques to drive your conclusion, right? So I was wondering what kind of typical methods you are using in the field. I don't think you just use simulation and then see the result and say this is some result you have. So I thought you must have some techniques, maybe some statistical analysis, something.
Yeah. Actually, first of all, about the statistical analysis. Honestly, I'm not expert about that. Yeah. So, as I mentioned before, Dr. Caber and then University of Florida Industrial Engineering, they usually use the eye tracker and then the statistical part. So, actually, I agree with you about we should develop more and then practically, develop the technology. And then I think our team, our priority is the practically how to install, how to use the best, how's the optimal, design the, in the real field.
I see.
Yeah, actually, after we suggest this result, actually, NCDOT, so make this type of intersections and then sign location in the real field. So we focused on that,
So my question is related to this process, right?
process,
So you may have a couple of decisions that, like what kind of shape, as you mentioned, where you put the sign, the locations of the sign, maybe the types of the signs you have to put, and so on. These are the decision variables, I guess. And you mentioned about the key performance indices, I guess. So in order to understand whether or not this is better, you might have some indices or metrics you are using against, I guess. So now you change some decision variables, like the location, shape, and so on, and
Yeah.
check the indices.
Yes,
and
yes.
then you change again.
Yes.
Is it the process you are doing, or is there any?
Yeah, actually, it is the great question is that it is the hard to answer directly, but I believe that the NCUTs, they actively our result, and then we need to do research follow up with the NCUT continuously. So before and after about the you're saying that like a before and after study, right? So after we proposed that this result and then constructed real field, and then as you know that actual constructing period is around 5 years, so long. So it is hard to get a response directly back and forth quickly, but we made some. That's why so we updated the manual guidance, regularly about the 5 years and 10 years, But honestly, this process is very slow. My tendency is so fast, so we need to get a result right after that. But many American is very slow, and then processing time is very slow. But I think this is also good, because I mentioned before, they are very cautious and careful. So
Great, thank you.
Thank you. Any questions?
I'm Kim. I'm level of professor division. And first of all, I really want to say thank you to your presentation.
Thank you.
So what I want to ask you is, have you ever thought about which or what place or region will have the most or a lot of influences if they install barcode or something like special shape of roadway? Because as I know, in Korea, we usually install the permissive left turn in like place which doesn't have a lot of population density or doesn't have a lot of cars. So I'm concerned if barcode or something have a waste of space or roadway. So have you ever thought about that perspective?
So, first of all, rarely no. North Carolina has a lot of land. So if the enough land, the location is enough. So I think the best one is the mud and the null cut. But usually, city use the typical standard intersection, right? And the suburban usually use the roundabout, mud, cut, and then more rural area, they usually use just the alway stop. Alway stop and then two-way stop, or not usually use the roundabout. because about the when it comes to when I explain about the conflict points, standard intersection conflict points are 32, and then MUT is half, 16, and then RCOT is the conflict point is 8, only 8, as well as roundabout. So we should develop more about this guidance. There are a lot of, as you can see, the 41 intersection and interchange type. There are a lot of possible way to combination in the future, right? Also, we have more factor like other factor like yield left turn and the signal and the signage. There are a lot of possibilities. So we should develop more.
Hi, I'm Curve. I'm from from Professor Anis Lab. So actually, we also have that the mobility hall. Did you come from there earlier, or have you checked it already?
Not yet.
Not
Right after
Okay,
seminar,
okay.
I'm gonna visit
Okay,
there.
actually, I have two questions. One is just a side comment question first. I saw previously during your masters, you updated the HAM 2015, the highway capacity manual.
Oh yeah.
This is just a side question. Will there ever be again a manual that is in SI units?
What was the?
Because if I remember correctly, the last manual that had both English units and SI units was 2010.
Unit.
Yeah.
Yeah.
Now it's purely English units.
Yeah.
Will there ever come again a addition with our SI units in feet, in meters or kilometers,
Yeah.
or will it still be just in feet?
Yeah. HCM. Now, yeah. I know the based on my acknowledgement is so the current HCM is used both. Yeah.
Uh,
Both both
current.
units. Yeah.
Oh, I remember the 2015 it only had English, but the 2010 had both SI and English.
2015.
Yeah.
Current one is not 2015, maybe
Yeah.
2020, right? Yeah. So at the time 2015, maybe
Was
English unit. Yeah.
And then my other question
I don't
now
remember
is,
because
so in traditional models, when we want to check if our intersection is good, we just use simulation to check if the speed improved, the VHD or VDD improved. Now here you're introducing simulators, so actual people driving. There are times that the simulation says that our model is good, it improves speed. But now when people now are introduced to that model as simulator, there are some characteristics of human factors conflicting with the model, like maybe it's too narrow, so people actually slows down much more abrupt. How do you resolve the difference between the simulation from our typical model to our simulators?
Oh, so your question is about the between the standard
Yes.
and other intersection type.
Yeah, now that we're introducing actual people driving, compared to the computerial generation that is just using those traditional models. So it doesn't take into considering human factors. So maybe my model will say that, this is good type of intersection, but when we actually had people drive it in simulator, possible it became worse because people that usually go straight would have to slow down because maybe the built environment was too narrow.
Uh-huh.
So do you resolve them by checking which is more appropriate, or which do you prioritize more, the simulator or the simulation?
Actually, I don't understand
so
exactly.
sorry.
Yeah, sorry.
Okay.
Yeah.
So let's say VSIM.
This-
Okay,
yeah.
in VSIM, there are no people driving it.
Yeah, no, yeah.
Yeah, so we just run it and then it says the intersection is good.
Mm-hmm.
And then now we have our simulator now, maybe putting it into Sumo.
Mm-hmm.
And then,
Sumo,
and then with the same setup of the intersection, they had different outputs. With people now driving it, the speed the output of the speed may be much more worse because now there are people slowing down and breaking up where our vsim just drives normally. So which will you, in terms of policy making, prioritize, the like, vsim or the one with the people driving it?
Oh, so first of all, yeah, we don't use the vSIM right now. We are using the, yeah,
Yes.
not yet.
Yeah.
Yeah, so we are gonna use also in the future, maybe next years, we're gonna, yeah, use the collaborate with, yeah, vSIM,
Yeah.
and then with other, we are gonna have a more three small simulator. We are connect
Yes.
them. So maybe we can do that later. Yeah, to see. But yeah, actually, I don't have, yeah, vSIM's, yeah, perspective for that.
Okay.
Yes, now. So
Okay. Then just a follow-up. How has the driver simulator enhanced your policy making?
policy making.
Yeah.
What is the main policy?
Policy making, I mean, oh, sorry, because I'm in transportation engineering, so I really do the models. So this in here, I don't put any human factors to it because it's just like mathematical computations and stuff like that.
Okay.
So they don't feel the built environment, if it's too slow or it's too big. Now that we're actually driving those inside the model, we feel more, how do you say that? More responsive.
Yeah, responsive.
Yeah, yeah.
Yeah.
So my model will say that this is good, but the actual people driving it will say it is not good.
Oh. Yeah, there could be a difference. Yeah,
Yes,
right.
exactly.
Yeah, yeah. So, okay.
So my question is, how do you resolve that? Which will you? It doesn't have to be recent.
Yeah.
Yeah.
So I think yes, great questions,
Yeah.
but I need to think about more. Yeah, yeah. So
Okay.
Yeah.
But my last question. So in actual, in like in America, the government, in terms of designing their intersection, they still don't use the simulator.
oh, when you make a real, yeah,
Yes.
intersection,
Yes.
I based on my acknowledgement, yeah, they don't use, yeah, they just installed, yeah, based on the just the manual.
Oh, okay. I
Yeah,
see.
and then we estimated after the constructing, and then we had a, yeah, we had an experiment based on the real,
Based
yeah,
on the review. Okay.
real site, and then we can propose the this is not good, this is good, and then this is the best look back angle, something like that. We can propose later.
Okay, I see.
But I think this way is, I think, yeah, this way is not efficient, but yeah,
You mentioned that it's
now
still slower, so it's a
slower
improvement.
than, yeah,
Okay,
improvement.
I see.
But I think this is American maybe way.
Okay.
Yeah, I think so. There are
Okay.
difference, yeah. So
Thank you.
no problem.
So if you think about it, it's an interesting concept, isn't it? Because here you may use some simulations or analytical model to design something. And here maybe the structure of the like intersections and so on. So you can do that. So what they do is, if I understand correctly, they try and see the pattern and then improve. We try and then
Yeah.
see the output
Yes.
and then we try. But this is a gradient method, isn't it? So you see, you change it and then you see the output. You try to go to the right direction. It takes longer time. But if you have enough samples, then this is optimal too.
Yeah, yeah,
So it's a slightly different perspective.
yeah. So I think, yeah, trial and error is very, yeah,
Yeah, it's very
we definitely need, yeah, depending on, yeah, in the futures there are a lot of, yeah, possible factors to change them. All right.
Excuse me, I have a question about the simulation process. I was wondering whether for the car following behavior of vehicles that are being simulated, whether physics-based or mathematical models like IBM or Gibbs model was used, or Whiteman model was used, or was there any other like data-driven approach that you have taken to kind of like simulate the behavior, the driving behavior of other actors,
Other actors.
or generally the actors in the driving simulation? Were they data-driven,
Mhm.
or were they physics-based models where you have to like kind of optimize some parameters?
Mhm. So about the
Because, excuse me, before you kindly answer, because I think for like softwares like vSim, we use Whiteman model, if I'm not mistaken.
what?
Whiteman model for crowd following behavior.
Okay.
Because this is kind of like, this question is kind of related to my research. I was wondering, and I'm also like trying to like create some driving scenarios for autonomous vehicles. So I was wondering whether you have taken this specific area into consideration as well.
Oh, okay. Actually, I'm not that expert about that, but yeah, new professor come, yeah, our department, civil engineering department, Dr. Chen, yeah, she's really interested in the reaction with other, yeah, vehicle actors. So yeah, she's going to install the new small simulator, and we are gonna connect them, and then we using the vSim. So maybe in the future, maybe yeah, soon, yeah, we're gonna yeah have an experiment with them, and then we should yeah consider like a car following or yeah the driver's guide, and then we're gonna buy more eye tracker, and then yeah other devices, yeah. So yeah, this is my yeah just perspective so far, yeah, right. But I can yeah email you about this perspective with Dr. Chen. Yeah, I also yeah interested in yeah that yeah area. Right.
One more question? Shall we thank our speaker?
감사합니다.